Hello everyone, and this is the second video in the maps series, and we are going to discuss practice problem longest substring without repeating characters. So let's quickly go through this problem. So it says that given a string S, find the length of the longest substring without any repeating characters. So the problem statement is simple enough. Let's quickly go through some examples. So first example is ABC, ABC, BB. So in this example, we can easily see that the substrings with unique characters are ABC, then BCA, then again CAB, then again ABC. So all these substrings of length 3 actually have all unique characters. We'll see that in this substring there is no substring of length 4 which has all the unique characters. Now again in this example we only have one letter in the entire string, so obviously the only possible substring which has unique characters is going to be of length 1, so the output is 1. Again in the string which is given to us we have two substrings which only has unique characters, so two substrings of length 3, so one is wke and other is kew, and in both of these substrings we have three unique characters, but there's no substring of length 4 which has all unique characters, so again the output is going to be 3 for this example. So one thing that we need to keep in mind is that when we are handling or solving problems based on subarrays and substrings, the two pointer approach or the sliding window approach is really helpful. So when we are talking about substrings and subarrays and we are trying to find the longest substring, longest subarray, or the number of substrings or number of subarrays given some constraint, the two pointer approach or sliding window approach majority of times comes in really handy. And why is that? Because the biggest constraint on substring and subarray is that all the elements need to be contiguous, and the two pointer approach is kind of the most optimal way of keeping track of a subarray and substring, because we need to only maintain the start and end, and we can store the information between these two pointers, and we can move these pointers to actually change the scope of the substring and subarray very efficiently. So in this problem as well, we'll try to explore a two pointer approach. Now obviously both the pointers will start from the 0th index. And what is the way of increasing the length of the substring? So the only way of increasing the length of the substring is actually moving the right pointer or the second pointer in the right direction. So let's see that should we move the second pointer or the right pointer in the right direction right now. So I just said right too many times. So first both the pointers are pointing at index 0. Now if I move one of the pointers to the right, now this is going to be the new substring, and we see that in this substring there are no repeating characters again, so it's a valid substring, and it is a possibility that the longest substring is of size 2. So now let's again move our right pointer. When we move this pointer we see that this is the new substring, and still we have not introduced any repeating characters, so now there's a possibility that the longest substring is of length 3. Now again let's move this right pointer, and by moving it right we see that we have actually introduced a repeating character. So a was already part of the substring, and we have again reduced a. Now what are the options that we have? So the options that we have are moving the left pointer towards right, or moving the right pointers to either towards left or towards right. So now let's explore. The moving right pointer towards right does not make any sense. Why it does not make any sense? Because we already know that the current substring has a repeating character. Moving it towards right would not remove that repeating character. We'll still have those repeating characters in the scope. So we cannot move the right pointer towards right. Now the second thing is that we could move this right pointer towards left. Now moving right pointer towards left also doesn't make any sense, because we have already explored this region. We have already got the maximum length substring for this region, and by going back to this region we would be again doing the task that we have already done. We have already got the answer for this region, so again moving the right pointer towards left does not make any sense. So the only possibility is to move this left pointer towards right, and how many positions do we need to move it? we need to move it till the time we again get a substring which does not have any repeating character, or the left becomes equal to right, because then again our substring under consideration would be of length 1, and obviously a single character is going to be distinct. So that is the algorithm we are going to follow. So now, as we discussed, our our only option is to move the left pointer towards left. So the left pointer will come here, and now we again see that in our current substring there are no repeating characters. So we have again got a substring where there are no repeating characters. So it again makes sense to move the right pointer towards right, to so that we can keep increasing the size of this substring till the point we again get repeating characters. So we'll again move this right pointer towards right. So again we see that we have encountered a repeating character. So again we'll follow the procedure of moving the left pointer towards right till we have eliminated this repeating, and by moving it just by one place we have again eliminated the repeating characters. So we can again start our procedure of moving the right pointer towards right. So now our right pointer will come here. Again we have a repeating character, we need to move the left pointer. Now we have again eliminated the repeating character, so we can again move the right pointer. Again b is coming twice in the substring, so we need to move the left pointer by 1 towards right. So when we move the left pointer, it comes at this position, and we can see that we have still not eliminated the repeating character. There are still repeating characters in this substring, so we again need to move this left pointer by 1. Now this left pointer comes at this position. Again, now we have removed all the repeating characters, so the right pointer can be moved by 1. Again there are repeating characters, so we need to move our left pointer. So first our left pointer will come here. Now again there are repeating characters, so left pointer needs to move by 1. Now again left pointer will come here. So left pointer moves towards right till we have repeating characters, or right becomes equal to left, because then we are only considering a single length substring. So now our condition is again satisfied, so we can again move our right pointer. Now our right pointer will go out of the scope of the string, so our loop will end, and we can see that till this point all the valid substrings that we have found, the maximum length substring was of length 3. So we got length 3 substring here, then again here, and at this point again CAB, and after that ABC. So these were the 4 substrings which were of length 3, and 3 was the maximum length substring. So in the end the answer will be returned as 3. Let's quickly go through the code for this solution. So this is the main method, length of longest substring, and we have the input string. Now, as we have discussed in our previous video, to track the frequency of the element, the most optimal method is to use a unordered map. So we are using a map frequency, which is storing a character versus its frequency, and frequency is a int obviously. And then we initialize 2 pointers, left and right. Both are initialized at 0 initially, so these will help us in tracking the bounds of the substring. And then we have initialized a variable called answer, and in this answer variable we'll be storing the final answer. Now this is the main loop in which we are going to do all our computations. So as we have already discussed, the loop runs till r till the right pointer or r goes out of the scope of the string. So we'll run this loop till the point r is less than the length of the length of the initial string. So I'll be referring the element pointed by the right pointer as the current element or the current character. So the first thing that we do is that we increase the frequency of the current element by 1 in our frequency map. So this is the new character which has just come into the scope of the substring, and therefore we have to increase its frequency by 1 in our frequency map. Now what we do is that if while increasing this frequency by 1, if this character if the frequency of this character becomes more than 1, So if the frequency of this character becomes more than 1, we need to keep moving our left pointer towards right till we have made the frequency of this current element as 1, because we need to only consider the substrings which has all the elements as unique. If the frequency of this current element is greater than 1, that implies that all the elements are not unique. So we need to keep moving, as we discussed, we need to keep moving our left pointer towards right till the frequency becomes 1 or the left becomes equal to right. So what we are doing here is that in the loop we are checking the same condition, that till the point we have to run this loop till the point the frequency of current element becomes 1, or till the point L is actually less than R. They are not equal, because if they become equal then we don't have to run this loop. Then we are checking if the element pointed by the left pointer exists in a frequency map or not. So this step was actually not required, because all the elements which are currently in the scope of the substring are going to be there in the frequency map. So this step, this if condition, is actually like a good check, but it wasn't required. So because logically we can say that it is always going to be present in the map. So now since we are moving our left pointer towards right, so the current element being pointed by the left pointer, its frequency will reduce by 1. So we have done that. And if the frequency of this element becomes 0, we remove it from the map altogether. So in these two steps, we have actually reduced the frequency of the element being pointed by the left pointer, and then we move the left pointer by one place. So after this complete loop, we'll make sure that the substring again being pointed by left and right pointer has all unique elements. So now that we again have a substring with unique elements, we just find the length of this substring. So the length of this substring is right minus left plus 1. And after finding the length of the substring, we'll update our answer. So answer will always keep the maximum of all the lengths of the prospective substrings that we have got till now. And after all this computation, for the next step we'll move our right pointer towards right by one position. And after this complete loop, our answer variable will be storing the maximum length of the possible substrings, and in the end we'll just return that answer. So let's quickly discuss the time complexity for the solution. So we see that we are actually parsing the entire string once. So in the worst case, the right pointer will move from 0 to n minus 1, where n is the length of the string, and r will also move from 0 to n minus 1. So both the pointers will be traversing the entire string, and the time taken by both the pointers to traverse the entire string is going to be 2n, because n for r and n for l. So the final time complexity for this solution is going to be big O of n. So you might have noticed that the questions we have been solving till now are actually standalone questions. The logic entirely does not depend on maps and sets, and maps and sets are just helper data structures to achieve that logic very efficiently. And this is going to be true majority of the time. There will be some standalone logic, and maps and sets will come into play as helpers. So maps and sets were actually a very small part of these problems, which, and the logic was completely something else. Like here we were using a greedy approach, by we were being greedy when we were moving our right pointer towards right to get the maximum possible length. So I hope that you understood this problem and the solution specifically, and how we use maps and sets to solve this problem. In case you still have any doubts or you did not understand some part of this problem, do mention in the comment section and I'll try to solve all your doubts. So I'll be soon back with another video. Till then, stay safe, keep learning. Thank you.